All right, little warm up today before we get into 1.9, the last thing in chapter 1 here. We're going to talk about some of those patterns, but we're going to use it more so in equations and see what we can do with that. Your warm up today is in your OneNote. We want to make sure you review all of your properties. So can you write an example of each one? So in effort's time, I need you to pause. See if you can write down an example of each of those. Pause it out. All right, welcome back. We're going to work on our table here. So if we have one kite, we're going to have 5 ribbons. 2 kites, 10 ribbons. 3 kites is 15. And 4 kites is going to be 20. Okay, so how many kites are there? So what we want to know is how many is it increasing each time? So it's going up by 5 each time. So if there were n kites, there would be 5n ribbons. Easy enough, right? So that's how we kind of build those. We know that's going to be there each and every time. What if there are 275 ribbons? Well, that means 5n has to be equal to 275. All right, it's divided by 5. So this is going to give us 5. We got a 2 left over, so 55 kites would give us 275 ribbons. Pretty cool. Works both ways, and it works. Eventually, we'll talk about how that's a linear equation and what's going on. So in our last lesson, we were talking about plugging in the x value. Remember, an ordered pair right here is x and then y. So we would take that x value and plug it in for x and see if it was true, false. We would call it open because we have some variables going on here, just as a quick review of that. But today, we're going to give you an x and a y. So is it a solution? Well, I don't know. How do we know? We plug it in. So let's do that. So y is 10, and 4 times 3 question mark over the equal sign. Is it the same thing? No, 10 is not the same thing as 12, right? So is it a solution? No, these can be written as yes, no, or true, false, just as a heads up. Often we're going to have it just the way you see at the bottom of the screen here is the ordered pair solution. And then we'll give you a couple different options. So we're going to plug these in. So remember, it is x and then y. Most common mistake that I'll see is students plug them in the order that we have them, even though the equation starts with y and then goes to x. So we have 20, is it equal to 4 times 5? Yeah, you betcha. What about negative 20? Is that going to be equal to 4 times negative 5? Well, that's going to be negative 20, negative 20. So that's another yes. We're doing pretty good. We're doing pretty good. Okay, what about this way? Negative 5 equals negative 20 times 4. Right? We didn't flip it around, did we? I want to start with that y value. There we go. Okay, so is negative 5 equal to negative 80? No, not today, not tomorrow, not even the day after that, whatever day that is. All right, so again, if you get, I'm going a little fast here, but if you're getting confused, remember put x over the x and y over the y. So you write 6 equals 4 times 1.5. All right, so here we're going to use distributive idea and see how cool this works. Do you know what 4 times 1 is? Yeah, it's 4. So what's 4 times a half? That's 2. So this is 6 equals 6. So it's yes. Right, so we're going to break up that 1.5. So we have some mini lessons in here as we go. So if that helps, use that idea. All right, so when we get up to linear equations in a couple months here, we're going to be talking about stuff like this. Is the ordered pair a solution? So I might say this question later when we realize that this is a line. Are these points on the line? So I could graph the line and see if they fall on there. I could plug in the values to see if it's true or false. There's a couple different ways we can do it. And that's what's cool about math, is we're going to keep building ways to clarify that you're right, or some things you're like, that doesn't seem right, so let's fix it. So it's all about that logical thought process. So remember, it is x and y, and this equation is x and then y, so it makes it a little bit easier. So I need 2 times 3 minus 5 times 1 equals negative 16. Okay, see what it did there? I just put in the x for the x, 3, and the y was 1, and went in for y. So we're in pretty good shape. Let's see, that's 6 minus 5 is it negative 16. I already put a no in there because that's not going to work. That's a big no thank you. Or as I like to say, nah, not happening. All right, 2, negative 3. That'll make more sense when we get to know each other. All right. Again, x is negative 3, y is 2. plugged them right in there, no big deal. So I get negative 6 minus 10. Is it negative 16? Sure is, negative 6 minus 10. So that is, yes, that's an answer. Now, do you think there could only be one? Or am I setting you up? I don't know. Let's figure it out. 2 times 2, right? Because 2 is here, x is 2, minus 5 times 4 equals negative 16. All right, so I get 4 minus 20 equals negative 16. That's negative 16 equals negative 16. Yes. All right, so those are both going to be solutions to that equation. Remember, we don't call it an expression. It's an equation because it has an equal sign. All right, next thing we have here, just trying to tie all this stuff together. So both Carrie and her sister Kim were born on October 25th. Hey, that's great. That's not my birthday, in case you're checking. All right, but Kim was born, let's see, 2 years before Carrie. How can we represent the relationship? All right, so I left a couple things blank in here. So that means when Carrie was 4, Kim is 6, right? Exactly, October 25th. So that means it's always going to be 2 years apart. So we can jot these things in here. Right? So let's say it in a couple of different ways. So if we said Carrie was X, what would Kim be? X plus 2. What if you want to write it the other way? What if Kim was X? And Carrie would always be X minus 2. So we have a couple of different ways to look at this. Right? Probably want to avoid the negatives, but either way, we'll deal with that. So I'm going to take just one of these equations and plot it on here. So this has me working backwards a little bit more. Okay, so when Carrie was 0, Kim was 2. So that's 0, 2. And then after that, everyone's going to grow one more year. Okay, so I could write both of these equations and put them both on the graph. Ooh. Did you see that? That was my hand. Yeah, sorry about that. Maybe it's better looking than my face. I don't know. Hey, I'm the only one who gets to say that. All right. So I just want to make sure that we can look at this in different ways. So we have a table. Right now it's written horizontally. We have a set of equations, and it really is based on what you want x to be. And then we could also take a look at the graph. And this is what algebra is all about. We have so many different ways to deal with this, and it's so fun to divide it up because some people are visual. They like graphs. Some people, they like a lot of numbers. I'm not going to lie, right? So they like the table. Some people are like, just figure out the table for me, give me an equation. And some people are way back here and they're like, I just like to read the words. And that's cool too. All right, Will runs 6 laps before Megan joins him at the track. They then run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? Right, so that goes along with exactly what we're kind of talking about. Okay. So if you want to know how much Megan was running, Megan ran exactly what Will did minus 6. What if you wanted to know based on Will? Will ran exactly what Megan did, but he ran 6 laps before she got there. Okay, so this is where it becomes a little bit more freedom, but with that freedom becomes a lot of responsibility. Are you responsible enough? You betcha. Okay, so just make sure it makes sense. So if I'm looking at this and I want to know Will, he definitely has more. So either way, I'm taking away from Will or I'm adding to Megan to get Will's answer. So both ways it works, we could plug that into a table, a graph, anything else from here. You just have to pick one way that you like it versus the other, okay? So we could say 0 with 6, 1 with 7, and 2 with 9. This would give you, right, who had less? Megan had less, and Will had more. All right, so hopefully that gives you some insight. All right, in your notebook, I do want you to try out this lesson check, just the highlighted ones. Okay, kind of steps through exactly what we just did. Is it a solution? So there's 2 of the same. So go back to the very second problem if you have trouble with that. And then we start looking at representing how those go together So the 3 and 4, those guys go together. And then number 7, what's the pattern? What's happening? So if it is a pattern.